let's see exactly how we can use this. And what we'll be doing in this webinar today actually is that first I'll be showing you exactly the processes that I've built on certain parts. And in addition to that, we'll also go ahead and build a simple process based on the SolidWorks whole wizard features. Okay, so let's continue now with the webinar itself. And first of all, with the SolidWorks whole wizard has been around for years, as far as I can remember. And when you're using SolidWorks whole wizard, there are many parameters that are available. There's a lot of information that is there. For example, you have the different types of holes. At this point, we support 4 different types of holes. We support the SolidWorks counterboard, tapped holes, countersink, and the simple holes. But besides that, each one of these also has additional features, such as some of them have what they call a near countersink. You'll have a counterboard that has a little countersink on top, or the under the head countersink at the very bottom, or a far countersink at the bottom, or head clearance, thread pitch. All of that information is available inside SolidWorks itself, and we now recognize them inside SolidCAM, and we were able to use them inside our machining process. If we take a look at the slide here, actually, you can see that there's a parameters. When opening up parameters, we have what we call whole wizard parameters. And you can see the whole list of different types of parameters, such as hole diameters, counterboard diameters, counterboard depth. All of this is available now within SolidCAM itself. Excuse me. But not only is it the features itself that we recognize, we're also able to build geometries automatically on those parts itself, on any edge of the hole itself. So in other words, if you have a specific diameter, it'll actually create a geometry that can be used in a profile operation or a pocket operation. All of this can now be done automatically and picked up automatically from the information that's given to us from the SolidWorks whole wizard. In addition, to make everything flow a lot easier and also pick up different sizes, we've added as well inside the machining process what we call conditional logic. All of this is now available within the machining process, and we'll actually see exactly how this works when we build it. So let's actually get started and see exactly how this works. We'll switch over now to my other screen. Okay, now what you see right now is a simple part that has a taps on it, okay? And before we actually start the process itself of recognizing this, let's first take a look at the part itself. I'm going to open up the part, and if we take a look, you'll see that this is built, these features here are actually features of the whole wizard of SolidWorks. Now, if I were to open up one of them, for example, this one over here, I'll just click on it and click on Edit Feature. What you'll see is there's a lot of information that's given to us inside the feature, inside the whole wizard. For example, the size of the thread, whether the end condition of the hole is going through the part or it's blind. The thread itself, is the thread a blind thread or is it a through thread? All of this information is available over here. It's given to us over here. Also, are we using a near countersink at the very top? All of this, again, is given to us within the parameters of the whole wizard, and we now recognize these. If I were to open up a different one, for example, let's say this one over here, you can see that this one is blind as far as the end condition of the hole itself. It's a blind hole, Plus, obviously, the thread itself is also blind. Okay? All of this information is within the SolidWorks whole wizard, and we now pick them up inside SolidCAM itself. Now, let's see exactly how we use this inside our machining process. Okay, first of all, within SolidCAM now, when we have it installed, there are two default installations processes that are included now in SolidCAM 2015 SP1, and that's the whole wizard process, SolidWorks whole wizard, metric, and there's another one for inch as well. And they're located in the proper tables folder. Okay. Let's see exactly how we use it, and then we'll go on an individual basis, see exactly how we also can build it as well. So if I were to go into machining process, and actually let me take a different view of the part itself. You can see the cutaway view, and you can see this particular part has holes that is, this particular case, the thread is blind and the hole is blind as well, but there's plenty of room at the very bottom to, so that there's enough room for the tap to go as far down as it needs to go to get all the threads done. This hole, for example, is also blind at the bottom, but there's very little room at the bottom. Now, this one is a through hole, but a blind tap, and this one is a through hole and a through tap as well. And you'll also note that each one of these is a different size. Okay, so if I start my machining process, you'll note the machining process contains 4 different machining processes within. In other words, these are the 4 that we support: tapped holes, counterbore holes, countersink holes, and simple holes. We'll start with the tapped holes, and you'll note I'll be using only one process for every single one of those options. Now, all I have to do right now is just do exactly what it tells me to do over here. It says, please create the geometry with the recognize geometry option. Okay, so I'll go over here, and I'll look for the recognize geometry option, and we have here recognize geometries. This actually recognizes the SolidWorks whole wizard parameters. If I were to click on this hole over here, it doesn't make a difference where, just click on the hole itself, you'll note that it picked up all the information. It says it's an M6. Okay, there's one hole here, and I'll accept that. The next thing I have to do is just tell it where my upper level is. So I'll pick it from here, click on that surface, and now click on Insert. When this is done, 3 operations were done. Now I'm going to reset this and do this now on a different hole. This time I'm going to do it on this one over here. Note, it's a different side, but I'm using the exact same process for this as well. Okay, click on it. You'll see it's an M8 by 1. My upper level, I can even write in the value of 0, and I'll do Insert. And let me do the same for my other 2. And then we'll take a look at the simulation and see exactly how they actually machine it. We'll see exactly what's going on in the process itself. Okay, and we have our last one. Recognize geometries. We'll click on this one over here. Put in a value of 0 and Insert. Okay, so we have our processes created over there. Let's take a look exactly at the process itself, at the simulation, and we'll look at it from this view over here. Simulate, and let's do this one step at a time. You'll see now, first we'll be looking at the first hole over here. You'll see that the spot drill will first come down, and it'll go exactly to where that chamfer ends over there. That's the exact depth it will go to. It recognized that automatically. Okay, again, this is information that was given from the SolidWorks whole wizard, so it knows exactly what the size is over there. Note, now the drill is going in, and it's the exact size drill that's needed for this operation, and it's going down exactly to where it needs to go down. Now let's take a look at the tap. The tap is not coming in, and note the thread is up to here. You see that the actual thread of the tap, the full thread of the tap is going down to that level as well. And there's plenty of room on the bottom over here. Okay, now we're going to go to the next hole. The next hole, again, the spot drill to its diameter. Note, it's a different diameter over here, but it still goes down to its exact diameter that it needs to. Same process was used. Different size drill to the proper depth as shown over here. And let's take a look at what happens when the tap goes in. Now the tap, even though the thread goes all the way up to here, but it sees that there's not enough room at the bottom to go all the way in. So it'll go down as much as it can without having the tap hit the very bottom of that hole. Okay, now we'll go to the next. The next one is a larger size even, and it's going to use this time a different spot drill, and again going to the exact size needed over there. The exact size drill. Now this is a through hole. Look what happens with the drill when it gets to the bottom. It actually goes through the bottom itself. It actually goes past the full diameter of the hole itself, giving it a delta at the very end. Now, let's take a look at the tap. The tap in this case will go all the way down exactly to where it needs to go. Okay. One more. Our last one. Our last one, you'll see it'll go down exactly to where it needs to go down. Again, the drill will go through the hole. Now let's take a look at the tap. The tap this time, since the through tap, the tap will actually go past the bottom over here. So all this was done in one process. Recognize all of these parameters and knows exactly how to deal with it. How we build it, we'll see in a few minutes. We'll actually build one. Okay, now let's take a look at a different part. Okay, we'll just go out of this part itself, and we'll load, let's load my counter bore holes. Okay, now this is a little more interesting because this, not only do I want to drill out the holes, okay, but I also want to take this and mill these counter bores out. Let's do a profile operation in it. Not only that, note in this particular case, we have counter bore where we have a countersink at the we have a near countersink overhead, and in this one has a mid countersink over here. Whereas this one has one on top, a near countersink, but no mid countersink. This one has a mid countersink, but no near countersink, and this one has no countersink at all. And we'll actually be able to machine every single one of those situations in only one process. Okay. Also note that you'll note also that I'll also pick up the geometries around the holes itself. So we'll start our process, our machining process, and we'll use the option of counter bore holes. We'll pick it. And again, we'll do exactly what I did last time. Recognize geometries. We'll click on that one. And you see it picked up that particular counter bore. Value I'll put in at 0 and insert. Okay. Now it created 5 different operations. I'm going to do reset. Now before I continue, I just want to show you something else. Note, show read only is turned off. I'll turn it on. And right now, I'm going to go towards the bottom. You'll note that in every single machining process, there are parameters that are automatically put over there that is taken from, that is from the whole wizard. Okay? Now, if the parameters of a particular hole is not being used, for example, we have here parameters for thread depth. This is a counter bore hole. There is no thread depth. It'll always remain 0 unless it is being used. So in this particular case, this will remain 0. Hole wizard hole diameter. You note there's a parameter called hole diameter, and there's also a parameter called, let me see a little further down over here, through hole diameter. What's the difference between the two? This is specifically for through hole. If it's a blind hole, then it uses the other one. Okay? That means a through hole will have, if it's a through hole, the value of that hole, the depth, the diameter will be over here. And this one will remain at 0. Please note this information because we're going to use it later on when we build our process that we're going to do in a few moments. Okay, let's get rid of the read only. We'll choose our geometry now. Recognize this time we're going to use this particular hole over there. Put in a value of 0. Insert. Okay. Let me do just this one over there. We'll do recognize geometries. That one over there. I think that'll be enough in this particular case. We'll insert. Now let's take a look what we have over here. You'll note the following. I'm going to do the simulation. This time when I do the simulation, I'm going to use the Solid Verify in my host CAD. Okay, so first you'll see that the spot drill comes down. Now note, the spot drill is not a spot drill that covers the entire diameter over here. That particular diameter on the outside, I actually want to break the edge with an actual chamfer mill, with a mill chamfer tool for milling. Okay, that's the way I decided I want to do these. Okay, now, note the next drill will come down exactly into that hole itself. Note that I specifically did it that the spot drill created a chamfer over here that's larger than the actual drill itself. This way, the drill will fit right into the center of that hole without worrying about that it's touching the outside first. Okay, so as we continue down, you can see it goes all the way down. Let's take actually the side view, and you'll see that it goes through the hole over there. Okay, now our next is our mill. Note it's doing a profile operation. I'm actually entering it using a profile helical step down into the part itself. Next, we have a chamfer. Now this is the actual spot drill I used in the very beginning. However, I want to put a spot drill, put a chamfer at the very bottom now. So I'm going to use that same tool, and it's going to go all the way down and create that chamfer as shown over there. The next one is actually, I'm using a different tool, and I decided to show that I can use a different tool such as a chamfer mill. And it'll come down and put the chamfer inside that particular part as shown over here. The same thing will be done with the next hole, the drill, the spot drill, the chamfer, and the same thing with the last one over here as well. Note, this one had a chamfer on the top. This one also had a chamfer on the top. This one did not have a chamfer on the top. So all I did was give it a small little break edge at the very top over there. Okay. Now, let's actually stop for a moment. And I'm going to load a different part. And based on this part that I'm going to load now, we're going to actually build a machining process. Okay. This particular part is a part, if I open it, show you the whole cutaways, this is actually simple holes. That's all it is. It's a simple drilled out holes. The differences between each hole, as shown over here, you have these two are through holes. However, this one has a little near countersink. These two are blind holes, where this one has a near countersink. So we have blind holes, through holes, with countersink, with the near countersink, and without one. Okay, so now let's start creating a machining process based on the whole wizard. Okay, So starting a new machining process, that's not a problem. Right-click on the machining process, new, milling. Let's just give it a name. I'll give it WEB, Webinar Hole Wizard. Okay, you can give it any name you want. Some people would like to do it actually according to a specific material or machine. Whichever way you want to do this, no problem. Of course, with every machining process, you have to add a machine. Assign it to a specific controller because different controllers have different cycles for drilling operations. So each one has to be individual. Okay, so I'll add a machine, and I'm just going to use the one that I'm using right now, which is the G milling 3-axis. Now, if there are any ones that are similar to this one, all I do is click on Add Similar, and it'll automatically add them to my list as shown over here. Now click on OK, and we now have our first machining process. The machining process at this point is called New Mac Process. That comes here automatically. It's empty, but it exists. Now, if I want, I could rename this. I'm going to just right-click on here and rename this to, let's call it Simple Holes. Okay. And let's just save this. Now let's start creating our machining process itself. We'll double-click over here or right-click and go on to Edit. And you'll note that we have a blank table here. No parameters are used over here. There are no operations here at all. So we'll start by creating our operations. I will create two different operations. One for a spot drill, and our second operation will be for a regular drill. That's all I want to do. Okay? So, right-click, adding a drilling operation. First thing I need to do is fill in the name for the geometry. Okay, when creating, again, just reminding everyone what the rules are when creating a parameter. The parameter cannot start with a number, and it has to be continuous. It can't be two separate words. So I want to put in a name over here called Simple Holes. I'll call it Simple and underscore holes. The underscore keeps it as continuity. Okay. I have my name on geometry. Of course, I'm not going to create one over here because I'm just as... Okay. Tool. This tool I want to use, I'll select the tool, and I'm going to create a spot drill. Okay. Now, it comes in hard-coded with numbers. If I want, I can give a hard code over here, give it a value of, say, 25 millimeters, and every single hole will use a 25 millimeter spot drill. But that's not what I would like to do. What I would like to do is use the standard spot drills according to their sizes, okay? And I want to have them according to the right size for the particular holes that I want to use. So I'm going to create a parameter. And the parameter I'm going to create in this particular case, you can name it any way you want to. The way I like to name it is exactly to make it as easily understood as possible. So I can write directly over here or click over here and go to Edit View. And I'm just going to write spot drill diameter. Okay? Now, before I continue, since I'm going to be writing the word spot drill a lot, I'm just going to take this and copy it. So it'll make it a lot easier for me later on. Okay. Just copied it, Control-C. Okay, so we have our first parameter over here. Next, we have our angle. Our angle, I'm going to do the following. Control-V, spot drill, angle. Okay? Arbor diameter. I'm going to do the same thing over here. Edit View, spot drill, arbor diameter. Okay. Now, as far as the length goes, I know people who like to put in, just leave it hard-coded. They really don't care too much about it. But I like to keep it as true as possible. So I like to put in, I'll give it a specific parameter as well. I'm just going to do Control V, spot drill, TL, exactly the way it's written over here. The same thing with this one. I'll paste it, OHL. Okay? And this one, I'm going to do the same thing, SL. Okay. Now, as far as my number of flutes, I'm going to keep it as 1. Because if we use later on a formula for the depth, okay, for the feed, as the tool goes down, as the drill goes down into the part itself, the feed is calculated off of 1 flute in any case, okay? So I'm just going to leave it at 1. That's going to stay hard-coded. You note we have our first tool over here. Now, I can deal with the data also, put in parameters for my feeds. And I'm just going to leave it right now because we don't have that much time. Okay. But by the way, you can see inside the machining processes that we created with the default one that's installed, you can see exactly what I did with the tool data as far as the feed and spin rates go. Okay, let's continue over here. Now let's go into our levels. Our first parameter, the upper level, I'm going to do the following. I'm going to call this spot drill, upper, whoops, my spelling is off, level. Okay, now my depth, since I want a specific part of my spot drill diameter, specific value of that value to go down to my 0 level, I'm going to use diameter value, and this drill depth, I'll keep it at 0. Now I need to, however, create a parameter for my diameter value. Now, what exactly do I want to do here? What I want to do here with my spot drill is I want it to go down and up into a specific chamfer size that I want to create. So what I'm going to do is give it a name that tells me something like that. Okay, so I'm going to call it spot drill chamfer diameter. Okay, and we'll see exactly later on how we determine this as well. Okay, now in my technology, I'm just going to set this at shortest distance. I can use any kind of drill cycle I want. I'm just going to leave it right now for G81, and I'll accept that. And you'll note we have our parameters already over here. By the way, I can save this now. I don't have to do save and exit. I can just do plain old save, and this is all saved. Okay. Now, if I do exit, you'll note it won't ask me anymore to save anymore because it has been. Okay, now let's go back in here, and I want to create another operation before I start filling in this information over here. My next operation will again be a drilling operation. This is for the drill itself. So as far as my name over here, I'm using the exact same geometry that I had before. So I'll just click on the arrow, go to user defined parameters, and use simple holes. The tool, I'll create a new tool, a drill, okay, and here I'm going to call this, let me do this, I like working this way so I can see the whole name, and I'm going to call this, I'm going to be actually a little lazy over here. I'm going to click over here and use user defined parameters. I'm going to use the actually very first one, but just delete what I have here. Now I have a new parameter called drill diameter, and I'll copy the word drill. Whoops, sorry. And like I said, I'm going to copy the word drill. Okay. My angle, I'm going to leave this hard-coded because my drills I usually use almost all the time are 118 degrees. Okay? And it's not really going to affect anything I need as far as the way I drill my holes, as far as the depth I need to go, and you'll see why in a few moments. Now my arbor diameter, I'll do the following. Let's use my parameter of my arbor diameter and just get rid of the word spot over here. Get rid of those spots. Okay, a little pun on words. And my total length, Control V, TL. And My outside holder, same thing, OHL, and my shoulder length. Okay, you see how easy it is just to create it. And my, if you use a specific method, like I do over here, just copy paste a lot. It goes very quickly. Control V and CL. Okay, and again, I'll leave that at 1. And I have my new tool. My levels, my upper level, I'm actually going to call this, I can use the same one I did last time, but sometimes I want to have a little more control on my upper level as well for the drilling. So I'm going to call this drill upper level. Now, my depth, this is going to be called drill depth. Okay, because here I'm using the depth. Now, what do I want in the depth? I want the full diameter of the tool to go to the depth that the whole wizard gives me. Okay? And in my technology, if I want to use here again, shortest distance, G83, and in my data, this particular case to have both QPEC and step down depending on what your post uses. I'm going to put values for both of them, so no matter which way you have it, it'll work on both of them. And the value I'm going to put in here is going to be step down. That's the parameter I'm going to use. The same thing with this one over here. User defined parameters, step down. Okay. And that's it. So I've created my process, and you can see we have everything here. Let's just save it to keep everything safe. Now let's continue. Now I want to start filling in values over here. Now I want to tell myself, okay, what's the first thing I want to actually fill in? Well, one thing that's going to be a common factor in everything is the actual diameter of the hole itself. Okay? Now the diameter of the hole itself, that's what my drill diameter is going to be. So I'm going to actually first deal with my drill diameter. Now, I'm going to bring up a picture, and let me explain something about the parameters here. Note the following. We have here different parameter names, okay? We have here different types of holes. Note, we have here a parameter at the very bottom here called hole wizard through hole diameter, and we have a parameter called hole wizard hole diameter. These are values that we are given. Now, if it's a through hole, this will have a value, and this will have a value of 0. The same is true for opposite. If it's a blind hole, this will have a value, and this will have a value of 0. Okay. Knowing that, let's put that to use. If I go into my drill diameter, now I'm going to use my option of conditions. And I'm going to give it a condition, and I'm going to say the following. If I go into my expression now, we have here hole wizard parameters. And I'm going to say the following. If my hole wizard hole diameter, that means if it's a blind hole, if that value and the condition I'm going to give it, I'm going to say it's more than 0. That means it's given, it has a value to it. Then the value I want you to use for my drill diameter will be that parameter. That means, however, else that means if it's not more than 0, it means it is 0. That means I have to use my through hole diameter. So I'm going to go here now and hole wizard parameters, and I'm going to use the option of through hole diameter as shown over here. Okay, we'll take that and we'll accept it. Okay, so I have my first parameter over here. Excellent. Now what do I want to do? I have to decide on the size of my spot drill. But before I decide my spot drill is going to be based on the chamfer diameter of the top of the hole. Okay? Now, we saw that there are holes that don't have a chamfer diameter, and there are that don't have a near countersink on top, and there are those that do. So for that, we're going to use a condition for my spot drill chamfer diameter. And I'll do the following. First of all, let me save what I did over here. I like saving as often as possible. And I'll click over here and go again to my hole wizard parameters. And I'll do the following. Sorry, to my conditions. And I'll do the following. I'm going to go to my hole wizard parameters, and I'm going to say, if hole wizard near countersink diameter, okay? If the diameter is more than 0, that means it exists, okay? So the value for the chamfer diameter will be my hole wizard near countersink diameter. So I'll go with the hole wizard parameters, and I will use the option of, sorry, hole wizard near countersink diameter. Else, what diameter do I have? I have the diameter of my user-defined parameter, my drill diameter. Okay? And that's all I need over there. So no matter what, I'll always get a value for my chamfer diameter. Now I can start with my spot drill. My spot drill, I'm going to do the following. We have standard spot drills. Okay? I have a spot drill, say, for 6 millimeters, 8 millimeters, 10 millimeters, 12, 16, 20, 25. These are standard sizes for spot drills. Okay? So I always want to use a spot drill that's larger than the hole that I'm going to, larger than the chamfer that I'm going to be using. So I'm going to do the following. I'm going to give it the following conditions. The conditions are going to be like this. If my user-defined parameter, which one I'm going to use? I'm going to use my spot drill chamfer diameter, is less than or equal to 5, okay? So any drill up to 5 millimeters, or any chamfer diameter up to 5 millimeters, the spot drill that you're going to use will be a 6 millimeter spot drill. Okay. Now, if I go to the else over here, I can also click over here, open this up, and I say else if. So that gives me now another field. I can say now the following. Let me just copy this over here. Instead of me opening up everything, Control C, and I'll say the following. If my spot drill chamfer diameter is more than 5, okay, and you see over here we have now and. Once I do that, another field opens up over here, and again over here I write spot drill chamfer diameter is less than or equal to, say, 9 millimeters, then the value of my spot drill will be 10 millimeters, okay? Again, else if, same thing over here, and I say is more than 9, and as you see over here, the spot drill chamfer diameter, I'm going to say is less than or equal to, say, 11 millimeters. The spot drill that you're going to use is a 12 millimeter spot drill. Okay? Again, else if. As you see, understand exactly what I'm doing over here. I'm going down. Now you can make this as tight as possible or as loose as possible. I'm going to do another one over here. If it's more than 11, okay, and Control V, it's less than or equal to 15, then use a 16, okay? At this point, I can, like I said, I can continue going on down, but just let me leave it at this point and say, if it's not any of these, use a 25mm spot drill. Okay? So for every single, I'm giving it actually a hard-coded value at the very end for specific size spot drills. Okay. Spot drill angle. Again, if there is an angle over here, now note, we have here, just a moment. In the picture, you'll see we have a near countersink angle. Okay? There are places where it exists and there are places where it doesn't exist. So I'll say the following. What's the angle I want to use? The spot drill will be follows. If the whole wizard near countersink angle, near countersink angle is more than 0, that means it exists, then the parameter that you will be using over here will be that near countersink angle. Else, that means if it doesn't exist, I'm going to hard code it at 90 degrees, at 90. So no matter what, you'll have the spot drill angle that you want. Now, my spot drill diameter, arbor diameter, in most cases, it's going to be the exact same as my spot drill diameter. So I'm just going to put in here the value of user-defined parameter, spot drill diameter. So whatever value I get from my spot drill, that's what I'm going to get from my arbor as well. Now, the spot drill depth, what I'm going to do is as follows. I'm going to use this parameter here. Sorry, Control C. For this, the spot drill TL, total length, I'm going to do the following. Control V, and I'm going to do times 15. Okay? This one for the outside holder, Control V, times 10. Shoulder length, times 8. You can put in any value that you feel that you need, but that's all I really need over here. Now for my spot drill upper level. Now, let's take a timeout and see the following. Right now we have a parameter here, but this parameter is a floating diameter. No, a floating parameter. In other words, the value that this will give you is any number, okay? Decimal point, anything like that. What I need it to be is a parameter where I can actually pick a Z level. So what I'm going to do is I'm going to create a new parameter, and that's done over here. I can add a new parameter, and the type of parameter is going to be called Z value, and I'm going to call it, pick upper level. Okay. I'm going to add this parameter. Now, right now, it's still not being used. So what I'm going to do now over here is my spot drill upper level. I'm going to go over here, go to user-defined parameters, because this is the parameter I just defined, and I'm going to use that parameter. Note, it is now over here. So whatever I pick is the value that's going to be put in over here. Okay, now let's go to the drill. My drill arbor diameter. I already have my drill diameter, so I'm going to have my drill arbor diameter the same as my drill diameter. So go over here, user-defined parameters. We have our drill diameter. Okay? I'm going to just copy this, Control C. And over here, my TL, I'm going to do Control V times 15. Outside holder, Control V times 10. Control V times 8 for my shoulder length, okay, and so on and so forth. Now my drill upper level, let's put that the same as my spot drill upper level. So I'm going to do that. User-defined parameters, and I'm going to use spot drill upper level. Okay. Drill depth. Okay, now what's the depth I need to go to? I want the entire depth of the hole to go exactly to where it wants, to the actual depth of the hole. Actually, take a look at the picture itself again, and we'll see the following. When I have a through hole, the parameter that it will give me will be hole wizard through hole depth. Okay, so I need this parameter. And note, it's the full diameter that we're going to get. If it's a blind hole, the parameter that I need will be a hole wizard hole depth. And again, the value will be of the actual depth of the full cylinder, which is why I use the full diameter option inside my drilling. So we'll do the following. The drill depth, we'll have it as a condition. Let's say, first of all, what I did up until now, and we'll do the following. Conditions. The conditions is actually a very powerful tool. Now I'm going to do the following. If my hole wizard parameter, hole depth, okay, is more than 0, that means it exists, that means it's a blind hole, I want you to use that parameter, that value that you get from the hole depth. Else, what you're going to do is use the through hole depth, through hole depth. Okay? Step down. I'm going to use my drill diameter divided by 2. Now, remember also at the very bottom of the hole, when I have a through hole, I'd like it to actually go a little past the hole itself. So what I'm going to do is very simple. I'm going to go back into my operation. Let me save what I did over here. And in the operation, I'm going to edit it and do the following. When I go into my levels, I'm going to use the option of delta depth. And I'm going to give it a parameter name, delta drill depth. Okay? Now, for this parameter, I'm going to do the following. I'm going to go into my conditions and say if it's a blind hole. What's a blind hole? Hole wizard parameters. The hole wizard depth. If it's a blind hole. In other words, if it's more than 0, that means that's what it is, a blind hole. The value of my delta depth will be 0. Okay? I don't want it to go any deeper. Else, my delta depth, if it's a through hole, I want you to go minus 0.3 millimeters. Okay? You can put any value over you want. I put minus 0.3. I know people put minus 1 or minus 0.5. Whatever value you feel comfortable with, just click on OK. And it's completely built. Okay? Now, let's save this. We'll go out of it. And let's actually put it to use for this particular part that we see over here. We'll go into, we have our machining process over here, and we'll go into machining process. Let's pick the very first one. Simple holes, recognize geometries, this one over here. We'll accept that. Let's put the upper level. You see, if I want, I can pick it from over here. And it has the value. Note at the very bottom, if I open up my read only, you'll see we have the hole wizard parameters. You can see which ones have values to it and which one doesn't. For instance, this is a through hole. So we have a through hole depth of 50 over here. Whereas my hole depth at the very top of this over here, my hole depth is 0. Okay? So you see exactly how this is being used over here. Okay. So we'll insert that. Sorry, I forgot to do something over here. Let me delete what I did over here. My mistake. Okay. I'm going to delete my operations. And I'm going to do the following. I'll go back into my process, and I know what my mistake was. My mistake was that in my tool diameter over here, my tool, if I edit it, you'll note in my tool itself that I created, let me go into here. Oh, we do have a drill CL. Okay. And we have a drill SL. Let's save it and exit. Okay, the drill CL did not come out over here. I'm going to give it a value over here as well. We'll give it a, we'll use this parameter over here, Control C, and my Control V, and I'm going to give it a value of times 6. Okay. Save, exit. Now let's do this. Machining process. We'll pick. Again, we'll click on recognize geometries. We'll click on that hole over there. We'll give it a value of 0. Insert. Okay, now it was all done. Reset. Let's do it for the next one. Now when I do reset, note all the parameters at the very bottom, my read-onlys, my whole wizard parameters are all back at 0. So we can start again, which is why we have a reset. Okay. Again, we'll use the recognize the geometries for this one over here. Put in a value of 0. Insert. Next. Same thing. Well, 2 more times we'll do this. Recognize geometries. On this one over here. Put in a value of 0. And last but not least, the very last one that we have over there. We'll recognize that one. And put in a value of 0. Insert. Sorry. Okay. And exit. Running my simulation over here. Let's run it on the side view as shown over here. You'll see, do it without the solid verify. Tool will come down exactly to the right edge, exactly to this edge over here. You can see the drill going all the way down, past the part. Okay, I probably made a little mistake over there with this particular tool. And the same thing for all of them. Okay, what I'm going to do is I'm going to close this part and we're going to run one more part. Now this part, we're going to run it from the beginning to the end and see how we actually use this on a regular, everyday part. This is the part that I want to use, and the machining process is the one that I built before. That's actually installed. And I'm going to use this one over here. Okay. Note the part itself has counterbore holes on different levels over here and over here. And you note we have several counterbore holes of the same type. So we'll go into machining, and we also have tapped holes, countersink holes. Let's do some of them. If I go into machining process, let's start with the counterbore holes, because that actually stands out in front of me. We'll click on counterbore holes, and let's choose my geometry. Now, when I recognize geometries, we have several options over here. If I only want one single hole instead of the whole pattern, okay, I can choose single hole, and I'll only get one hole put over there, okay? Even though it's created in a pattern, it only gave me that one hole over there. I can delete that, unselect it. Now, we also have an option of if it was whatever was created in the wizard, and if it was created with patterns as well. So if I click on the hole right now, note, it'll take not only the wizard, but everything that was part of the pattern. We have this and this over here as well. Okay, this was the actual original wizard creation, and this was the pattern of that creation. We'll accept it. The upper level in this particular case will be over here, and we'll insert that over there. That was created. Let's reset this, and now I'm going to use it for a different set. Recognize geometries. We'll do it on these holes over here. Okay, recognize all of them. the level in this particular case is down over here. Okay, and we'll insert those operations as well. I'm going to exit now, and this time I'm going to use my tap tools. I'm going to use it, say I recognize, we'll go to these holes over here, this set over here. My upper level in this particular case is over here. Insert those. And then we'll reset it one more time, and we'll do these holes over here. These holes down over there. Accept it. My upper level in this particular case is over here. And that's it. Now, of course, I do have other holes here as well. Simple holes, but I think you understand exactly what's going on over here. Let me just run the simulation on all of these operations. And let's use actually the solid verify simulation. And you'll see that every single one of those holes was tapped out, milled out exactly the way it needs to be, with the proper chamfer at the edges. Over here as well, the taps, you can see it has a little chamfer at the end of the tap as well. All of this was done very simply as it recognizes the whole wizard parameters. Okay, that's it. Let me just go through the questions. Okay. There was a question, how can I copy this the set of processes parameters to another SolidCAM computer or anywhere else for that matter? Okay. First of all, if I go to machining process, if I right click on this particular one, okay, we have here an option of save as. Okay, this is now available as well. I can go to save as, and I can save it wherever I want to. I can go into my SolidCAM 2015 over here, users, and I can save it over here if I want, or wherever you want to save it. This entire process will be saved in that location. Okay? If I were to go there now and open up that particular location, users, public documents, SolidCAM 2015, users, you can see that it was copied to that location. Okay? Okay. If there's already a finished tool table, how can I connect it for an automatically tool selection for this? Right now, you would have to bring the tool table in here first. If there's a tool table inside over here, and the tools match the tools that are in here, it'll use those tools. Okay. Thank you very much. This webinar has been recorded, and we will see you in our next webinar. Take care, everyone, and have a great weekend.